For today's lesson, we're going to talk about, in general, what the difference between linear and quadratic things are. We're going to do a couple of different situations, but very basic things just to get you to understand linear versus quadratic. So what do these words mean with respect to mathematical expressions? So linear means line. Okay, so remember line is in there. So this is any expression or any equation that makes a line. We see that when things are to the first power. So linear, we want to remember it makes a line, okay, and first power. So those are really important things. Quadratic is, quad is like squared things. So this is anything to the second power. And it makes a shape that looks like a parabola. And we're going to talk a little bit more about parabolas later, but parabolas are U-shapes, kind of like that, on the graph. So they can open upwards or they can open downwards. And then anything that doesn't fall into those two categories is other. So the first thing we're going to do is we're going to look at some expressions now that we understand what the difference between linear and quadratic are, and we're going to try and figure out whether they are linear or quadratic or something else. So the first expression, pretty straightforward. We have negative 9x plus 1. Well, the negative 9x, so this is x to the first power. Okay, x to the first power, so that means that this one is a linear expression. Okay, the second thing that we have here, 4x squared minus 2, this is to the second power, so second power, and the other thing doesn't matter, the constant doesn't matter, so this one is a quadratic expression. Okay, if we look at our third expression, we have two binomials, x minus 1 times x plus 3. Each binomial is a linear binomial, but the expression in total is what we get when we multiply those two together. Since you guys are all experts in multiplying and foiling out, so you should figure out, you should be able to identify that this is really x squared plus 2x minus 3. And then because we have the x squared term, this gives us a quadratic expression. If you look at the final example that I have here, again we have two binomials, two linear binomials that we're multiplying with each other, and then we're subtracting out some other term, the negative 2x squared. So if we multiply out our two binomials, we get 2x times x, which is 2x squared. 2x times negative 3 is negative 6x. Then 2x times x gives us plus 2x. And 2x times negative 3 is negative 6. Combine our two inner terms to get negative 4x. But this negative 2x at the back end cancels out with the 2x squared that we calculated. So all that's left is negative 4x minus 6. Since that's what's left, that becomes a linear term. Okay, any questions? Bring them to class. The next thing that we're going to do really quickly is we're going to look at parabolas. So I have two parabolas here, and you see they both open upward, but they can open downward as well. And we're being asked to identify the equation of the line of symmetry, the vertex, and two mirrored, also known as corresponding points. Okay? Well, if you remember, symmetry is that line where something mirrors itself. It's exactly the same on both sides of the line of symmetry. If I look at my first parabola, the line of symmetry is right down here. That means that that is the vertical line that has the equation x equals 2. Our vertex is always on the line of symmetry. The vertex is the point 2, -3. So that's our vertex. And then some other points on the parabola. We have one that's here. We have another nice point that's right here. And there are plenty of other points, but those are the really nice ones that we can find the ordered pairs easily of. So this point is 4, 1. Each point on a parabola has a mirrored point on the opposite side of the line of symmetry. So over here, if I look, there's another point right here at 0, 1. That's the point that is mirrored or corresponds to 4, 1 on this parabola. Let's do one more just to make sure that we've got it. So again, our line of symmetry is this vertical line that cuts the parabola in half, and that's at x equals -2. So that's our equation of the line of symmetry. Our vertex is right here, and that's at the point -2, 2. And then if we look at some other points, here's a point on the parabola. It's at -1, 4. And the mirrored point to that one, or the corresponding point to that one, is at -3, 4. Notice that the y values are exactly the same at those mirrored points. And that's the basics of quadratics and parabolas.